Okay, so again, the normal probability distribution, what it does is that we do not longer have bar charts like before. Before we were having bar charts, if you remember. So that's why you needed to move from 1 or 2 or 3 or 4. And you needed to decide if we were counting it from 4 and above or from 4 below or at 3. So we were trying to decide where it should be stopping. When you're working with a normal probability distribution, you're working with continuous elements. So we don't have to jump from 3 all the way to 2 or from 3 all the way to 4, because in reality, there can be numbers as close to 3 as 3.0001 or 2.99999. And in that case is the example that I was explaining you before about the hair strand, that in this case, if we are, the probability is similar to the area that we are covering, then it doesn't make too much sense that if we are trying to calculate a given probability, for example, in here for 45, that we subtract 0.00001, or that we add 0.001 so we can be super close to the number, but not the actual number. Because in reality, that probability, it's close to 0. So we can treat it like if it was 0. And therefore, when they tell you, calculate the probability at most 45. So in that case, you will say, okay, from 45 and below. Or when they tell you that at least 45. So you calculate from 45 and above. Because you don't have this bar chart, you have a continuous. So in here, let me see if I can make it, but it's like you were having hair strands covering one after another one, super small. And those are areas. All that tiny line, slim line is giving you areas. So you have thousands, millions, and I don't know, billions of them. You have infinite numbers of line, one after another one, like hair strands, one after another one, matching those values. So it doesn't make any more sense to be moving before or after the number, because it is continuous. So in that case, you can stop at the exact value, no matter if it is at most or less or equal to, because that element that is so thin can be not depreciated, but not evaluated according to the calculations that you're going to be making. They won't affect that much. Okay, class? So that's the biggest difference that you're going to be facing when working with, I'm missing one window and I don't know where it is. When working with normal distributions. Yes, class?
Yes.
Perfect. You're super quiet, so I didn't know if I was talking to myself or not. Margot, is everything okay?
Yes.
Yes, perfect. So how is this going to be changing? That's the first change that we have with with normal distributions instead of binomial distributions. So we don't have integer numbers to be swapping. It's just continuous. So whatever number we get, that's the number that we're going to be analyzing. The second part that changes is that as we have a normal distribution, now we are able now to calculate means. We have standard deviations, and we have any more elements that before didn't make any sense. We again can go back to the median, to the mode, and all of them give us information about the behavior of that variable. So all of those considerations that we have already learned in between binomial elements and normal elements, when we go to the exercises, we're going to be figuring out that as we have a mean value, then we're going to be expecting, pay attention class, we're going to be expecting that a higher probability is concentrated on the mean value. Yes, class?
Yes, teacher.
And as we move to the size of the mean value that is considered, then that probability should be getting smaller. And by smaller, look at the height of the lines that we have here. Another important element is the distribution, or in this case, the standard deviation. Oh, again, it's when I'm sharing that it gets super slow. So we have the standard deviation, and in this case, the standard deviation, what it does is that if we have a very small standard deviation, then remember the 3 sigmas that I explained you last class? That when we have 1 sigma was about 60%, 2 sigmas was around 90%, and 3 sigmas was close to 99% or 100%. So when the standard deviation is small, then instead of being super wide, we have a narrower, and in that case, it will look more like a peaky mountain, like very, like this. Very narrow on the base, and you can identify very clearly how high it is. And when you have bigger standard deviations, then that means that instead of having 1 standard deviation to the sides, then you have 1 standard deviation to the sides. So then when you have 3 of them, rather than being here 3, you have 3 of them on the side, so it gets super stretched out. So it's like if you were taking it from the corners and stretching it. Yes, class?
Yes.
Those elements, in that case, when you have a small dispersion, you will see a lot of the concentration on the mean value with a very, very high probability. And if you take the same white from here, also having the value of the standard deviation being so big, then you will have a smaller concentration on this part. Yes, class?
Yes.
So dispersion is going to be affecting as well how much of the concentration you have or the probability that you have for those elements to happen near to the mean value. And that's why when we solve problems, most of it, or not most, all of them, are related to concepts of the mean value, the standard deviation, rather than the number of elements and the probability for success or failure. Yes, class? So let's make an example and start to identify the main differences that we have between the binomial versus the normal. So in the binomial, remember that we were checking for, in binomial, I think in this binomial, we were working with binomial. We had the number of elements or the sample size, remember? We have the probability for success. And what other element we had? Do you remember?
The value, I don't remember what is
Discrete counting.
The value that we were working with, right? The input constant or whatever it was. Yes, the value. So those were the only 3 elements that we needed to work with. And then we analyzed if that value will be accumulative or exact. Now that we're working with a normal distribution, check how the exercises look different. They say, weekly income of the shift supervisors of the glass industry is governed by a normal probability distribution with an average of $1,000. So now you get information about the average value. And you also get information about a standard deviation of 100. And then the question says, what is the probability that a randomly selected supervisor receives between $950 and $1,100 per week? An important part to check, it's also our units. Check them that they are like weekly, monthly. So we have to check that part. So we don't have any more information about the sample size. Do you notice that?
Yes.
We don't have information for probability of success neither. We still have values. We can identify those values here. So those values are still there. So that's the only one that stays the same, but the rest is totally different. So now when we go to calculate the probability for normally distributed elements, now what we care for is the average, that in this case is similar to the mean value. So we need a mean value. Let me see if I can. We have a mean value. And we have as well a standard deviation. Yes, class?
Yes.
And that's how you're going to identify them when you work with a binomial distribution or when you work with a normal distribution. Miss, are they different in the sense that we apply them? No, they're giving us the same information. They're telling us how much possibility or which is the probability that a certain behavior is observed. So the benefit of this is exactly the same. The difference is that if my analysis of the element or variable that I'm trying to analyze is discrete, I cannot apply the elements of a normal distribution. Or if the element or variable is continuous, then I cannot apply a binomial distribution. It's not possible. That's why we have like two tools that are different because the variable under study are different. And therefore the information where we calculate it is totally different. But how we use the information is exactly the same. So, questions so far? Are we able to identify the difference in between a binomial probability distribution versus a normal probability distribution? Are they clear? Are they evident? Yes?
Binomial es solo cuando es, ¿cómo se dice? Éxito o fracaso, ¿no?
Éxito, fracaso, and it's discrete, right? And you have a probability for that success and failure. A normal distribution, what do we get?
Promedio y la derivación estándar.
Exactly. So when you listen anything about average and standard deviation, normal distribution, percentage of something happening, binomial distribution. Yes, class?
Yes.
And on Minitab, they look exactly, they're pretty much the same. So you go again to calculator, then you go to the probability distributions. In PC, they're gonna be asking you first if it's binomial or normal. In that case, you select normal. But on Mac computer, they're gonna be asking you again if it's cumulative or if it's probability density. And that information is exactly the same. Again, when you're working with density, is because we want an exact value. And the cumulative is still for ranges. Ah. Yes, class?
Yes.
So in this case, that says that between $950 and $1,100 per week, what do you think it should be? Density or cumulative?
Acumulada, ¿no?
Cumulative.
Cumulative is range. Yes, class?
Yes.
Questions? No?
No.
So now we go to probability distribution, and then we select cumulative probability. We have to switch it to normal, which is here. And if you see, it doesn't ask anymore for the probability, neither the trials, it just says, which is the mean? So which was our mean value? Or average value?
It was
1,000.
1,000.
1,000, perfect. So we select 1,000, and the standard deviation was
100.
100.
100, perfect. And then we have a value. The values behave exactly the same as binomial distribution. So if we make it 2, it will be from 0 to 2. If we make it 100, it will be from 0 to 100. In this case, we want from 950 to 1,100. Which values do you think we should input?
950 to 1,000.
But it doesn't accept ranges. It's only one value.
Oh,
So what do you think we're gonna be needing to do?
I mean, in between the
950.
range, maybe.
950 and 949 and subtract it.
No, again. And again, which was the last part? The one that says subtract? I didn't get to see who it was.
I do.
Gabino, what were you saying about subtracting what from what?
You put 949 and subtract it from 950 and then get the 1,100.
Okay, let's see if we can get it clear now.
You calculate the 1,100 and you subtract the 949.
This is my normal distribution, okay? Pay attention, everyone. Yes, class?
Yes.
I'm gonna be muting you a little bit because I'm just trying to check what is slowing out my computer. Maybe it's the second monitor that I will have to drop it. So pay attention. We want all the probability that goes from 950, all of it.
Ah, ya, maestra, se me hace que. Bueno, ay, perdón, ¿puedo interrumpir?
Yes, do it.
Sacas lo de afuerita y se lo restas, ¿no?
To whom?
O
So
sea,
what is the
o sea,
thing in the outside, Victor, for you?
lo que está ahí blanco. Pues lo que
But-
no ha pintado, pues.
From
O sea,
the right
de-
side, the left side, which one?
del 900, por ejemplo, del 950 al 0.
Okay, so we take
Eso.
all the probability that we get here from 0 to 950.
Ajá.
We don't want that, right?
Ajá.
So we want from 0 to 100 and 1100, and from 950 to 1100. So what do we have to do?
Teacher, se podría hacer de que, o sea, sacas lo que hay del 0 al 1100 y luego lo que hay del 0 al 950 y se resta.
Ajá.
Perfect, amazing. That's exactly what we need to do. And if you remember that concept, you learned it when you were in high school with integration. That's what integrals do.
Pero no se pueden restar porcentajes o lo que se resta es cuando ya los tienen los porcentajes.
So in that case, the probability, let me draw it here so we keep it. The probability for 1100, it's all the way from 0 to 1100. But the thing is that, as Victor was saying, we don't need the probability that goes below 950. So what if we subtract that part? And that's where Alejandra went and complemented perfectly and said, okay, from everything that we get the probability from 0 to 1100, let's subtract the probability that we have from 950. And that will leave us with only 950 to 1100. This is exactly the same formula for definite integrals. Remember, the number from the right side minus the number from the left side, because I want to take out what I don't need.
Yes. Yes, yes.
So that's the only difficult part. And it's not difficult. I will say like longer part to solve when we are working with normal distribution, because when we have ranges, we need to get one value minus the other one. But as Minitab does it super easy for us, then we just do it twice, one with a 950. Do you agree?
Yes.
Maestra, una pregunta.
Yes.
En el examen, o sea, nos va a poner así de que problemas
Yes, of course, that's what we're.
y vamos a poder usar el Minitab.
Yes.
Ah,
Someone
ok.
did just ask it that before we
Maestra,
went to break. Yes, Gabino.
si el rango es de 950 a 1100, ¿no se haría un número atrás para incluir en el rango el 950? Porque
No,
el rango,
because remember that you're working with continuous distribution. And the probability only for 950, it's 0. So it doesn't affect you. It's gonna be 0.000. Is what I was explaining about the area from your hair strand. It's like if you were saying, when I explain this in math, what I say is, imagine that the area for a given number is like a grain of sand in a beach. If you just take one small piece of sand and take it from the beach, is the beach gonna be looking empty? Are you
No.
gonna be saying, oh, someone take out a piece of the beach sand from the beach? Now we have a terrific problem. No, right? Because there are so many grains of sand around the beach that just taking one of them out doesn't even notice. It's not noticeable. Even if you take a bucket, you won't notice it because there are so many grains of, there's so many sand in the beach that it's not possible for us to visualize it. So in continuous variables, when we work with single elements, even though we're seeing the number like a whole number, we are in our mind, we're seeing it actually like if it was binomial, but in reality it's continuous. So that 950 is just a small strand number on your area. This is a strand of a hair strand. So you can, it's close to zero. So that's why you can take it out because it won't affect that significantly your calculation. Yes?
Yes.
Yes, Gabino?
Yes, teacher.
Perfect. So I hope the analogy helps. I always try to use like visual things so we can like say, yes, it's true. Like if I take a grain of sand from the beach, it won't be noticeable. So that's exactly why we on normal distributions are able just to put the number and not subtract. Because, and let me show it here.
So the final result is 54%.
I'm getting there. Just wait, because are you seeing my computer driving crazy? I think it needs holidays. I think I have too many videos that I have done. And that's why it's getting. So in this part, what we need to do is subtract both of them. So we have 0.84 minus 0.30. So it is indeed 44%. And going back to Gavino's question, Gavino,
Yes, teacher.
and also for the rest of the class, of course. Let's imagine we have here the 950. The real probability for 950 is only this line.
Mm-hmm.
But if you subtract and say, I'll make it to 949 over here, you are not just taking out this small area, ready? But when you do that on continuous distribution, you're not just jumping from one value to another one. What you are doing is actually taking a whole value with a bigger probability out when you move from one element to the other one, because now it is continuous. So they don't jump from number to number. They are ranges of probabilities. And the area from one number to another one is super big. That's why we stop exactly at the number, because it's just this purple part versus that big or yellow part that you do when you move to one value before or after. Yes?
Yes.
Is it clear now?
Yes. Teacher, but the result is 53.28.
Yes. I'm sorry. I'm just noticing that I subtracted incorrectly.
That's okay.
53. Thank you. I'm so stressed with this computer being so slow today that I'm doing crazy stuff.
Don't worry, teacher.
0.53. Yes?
Yes.
And that's your answer. And this, dear students, this is the most difficult example we will solve. Anything else is way easier. So
Yes.
let's practice. Do you agree?
Mhm.
Is the concept understood?
Yes.
Class, before we move, which is the interpretation of this 0.53 or this 53%? What does it mean?
It means the probability that randomly selected supervisors receive between $950 and $1,000 per week is a
Exactly.
salary probability.
Exactly. So this is very important. Remember, it's not about just taking the calculations, but actually making interpretations of what we're working with. So in this case, we can say that the expected weekly income or the probability that we have a supervisor from the glass industry is very specific. If we take a people from that as a random sample, that we have 52% chances that that supervisor has a weekly income in between $950 and $1,100,000 per week. Okay. So always go back to the interpretation. Don't just give me the numbers. Right now I can write, but I promise you that when we finish the class, I will put all the interpretations in there so you can watch them correctly. Yeah.
Yes, thank you.
Yeah, even for clicking, it's like super low. Look how much it delays to make a click. Oh, computer, I will have to reset it. Okay, so let's go to another exercise here. And again, let's start since the beginning and read the problem and tell me, class, is this problem a binomial or a normal distribution problem, and why?
It is a normal distribution because it contains the standard deviation,
We have the standard deviation. What else we have?
the average,
The average.
and
And it says in here that
it
normal
says there.
distribution.
Yeah.
Exactly. Some problems in your test won't say that it is normal. So that's why I'm training you to identify as well. And also in real life, no one tells you if it's normal or binomial. I think those are one of the huge problems we always get. So it's like, always remember, discrete, they don't have mean, they don't have standard deviation. Continuous, if it's normal and it has mean and it has standard deviation, I can calculate anything. So it says, what percentages of refunds are greater than $3,000? And by percentage, what does it mean?
The probability.
Probability.
Probabilidad.
Perfect. So they can ask us many ways. And that's why I always say, like, the percentage of. In reality, it is not common for us to say, oh, the probability of something. We say, oh, the percentage that something happens is like the more natural way to say it for people that it is not a statistician or an analyst. So, and it says greater than 3,000. So from where to where do we want to calculate these values?
From 3,000 and on.
So if we have a normal distribution, we have a normal distribution with the mean into 207.08. And we want it to be at 3,000. And more. So that means we move from 3,000 to the right or to the left?
Right.
To the right. We want all of this part. Do you agree?
Yes.
So question number 1 for part A. Is it cumulative or is it density?
Cumulative.
It's cumulative. Class, a hint. Does it make sense that they ask you for a probability density? I'm missing an M here.
What?
No, it's cumulative.
No, but does it make sense that in a given problem, they ask you for an exact probability?
Yes.
Yes.
Yes?
Well,
With normal distribution?
in normal, no.
Normal.
But in the other one, the binomial, yes.
But in the normal way, it doesn't make sense.
Oh.
Mm,
Normal.
So normal cannot be density
Why it cannot be density?
because it is not specific, it is ranges.
But what if they tell you, give me the probability that of people having refunds exactly for $3,000? What if
Porque la
they
probabilidad es
tell-
muy chica, ¿no?
Exactly, it's close to 0. So in the case that they ask you, oh, on a normal distribution, tell me the probability that the refunds is exactly $3,000. It's gonna be close to 0 because we already say that the probability is the area of a hair strand. So it doesn't make sense. So in normal distribution, they're always going to be asking us for ranges. Yes?
En este tipo de casos, si nos dijeran de que es 3000 exactos, la respuesta es no, ¿verdad?
The answer will be 0.
Sí, o sea, pues que no existe, que no hay.
Yes,
Sí,
it's
es un número
zero.
exacto.
It does exist. It's 0.
Ah, ok. Es que en prepa le poníamos que no. Bueno, al menos eso nos dijo el profe.
Yeah, it's okay. It does. I mean, in this case, I just want you to remember why it is not logical to ask for that probability, because it's not that you cannot calculate it, but it is 0. It's always going to be 0.
Ok.
Okay.
Actually, if you ask Minitab to do it, let's do it. Let's go with the calculations. Now we go calculator. Let's make it cumulative first, which is the one that we want, and then I'll switch it to density so you can see what happens if you do it with the exact number of Minitab. So we wanted it to be normal mean value.
Yes.
How much is the mean value?
2708.
Perfect. Margot, how much is the standard deviation?
$650.
Margot is not here. I'm checking you, class. 650, thank you. And then, Caro, which value are we gonna be testing for this part? They're asking it to be greater than 3,000.
3,000.
The 3,000. We don't subtract, we don't add, we exactly put the 3,000. Yes, class?
Yes. Teacher,
¿Por qué
Teacher.
normal, teacher?
teacher, you forgot I think.
Teacher, la pantalla de Margot.
Wait, it didn't change. I don't know what happened.
Teacher, you forgot to put the standard deviation. You put,
No, I didn't put the, yeah. Wait, I swap it. I overwrote my numbers.
yes,
Thank you,
Teacher.
thank you.
Teacher, why value is 3,000?
Because they're asking us for greater than 3,000. Yes?
Okay.
Teacher,
And after that, we're gonna be seeing if it's that number or we need to subtract something. But first, we just need to remember that whatever number they tell us, if they just give 1, we do it with 1. If we have 2 because we have a range, we use the 2 of them. Alejandra.
teacher, le quería decir que la pantalla de Margot se trabó. Por eso
Okay.
no le contestó.
Okay. Is she
Sí, por
okay
eso.
now?
Sí, ya. Creo
Okay.
que sí.
Okay, super. So now let's go to the interesting part, that is making this information match. We want greater than $3,000, but in here we have the probability for 3,000. Remember this 3,000? Where does it discounting it from?
From 0
Excellent.
to 3,000.
From 0, exactly, from 0 all the way to 3,000.
Más a uno le quitas el 67%, ¿no? Ya lo que resta.
Exactly, because what we want is this part. So if we remember, all probability from all the distribution, in this case from 0 to whatever number it should be, it's always 1. It's always 1. So if we subtract to 1 the probability from 3,000, then we have the probability that it could be greater than 3,000. Yes, class?
Yes.
teacher.
Everyone okay so far?
Teacher, tengo una pregunta, o sea, porque antes le hacíamos de que tomamos un valor, o sea, de que agarramos de 0 a, por así decirlo, 2,999 en este caso. ¿Por qué no hizo eso ahora?
That's what I just explained about what happens when you move one whole number before in continuous distributions.
Porque no, o sea,
Remember, probability is ahead,
es el valor.
and that one is 0. But if you move all the way to a number below, you're taking a lot of the probability out. Yes?
Oh, okay. Yes, yes.
Yes.
Maestra,
Sorry, thank you.
Who is talking?
Mariana,
Yes, tell me.
Margo me dijo que si le podía decir que está batallando mucho para volverse a meter.
Okay, just tell her to keep trying and that the session is being recorded. So let's see what happens. I am also having trouble with my computer. Maybe it's something about the network. So
Maestra,
thank you. Yes, Sebastián.
ahorita me desconectó por unos 3 minutos. ¿Qué fue el último que dijo, que explicó?
The last part that I explained, that we needed to subtract 1 from the 3,000 because the 3,000 is from 0 to 3,000 and we only want the right side.
Ah, bueno, también es la de cuando había preguntado cuando es greater than 3,000, usamos 2,999 o 3,000.
No, in continuous, you always use a number
Ah,
because it's continuous. And if you use a number below, you're taking out a lot of the probability. So remember this probability at this given number, it's 0, it's close to 0.
Okay.
So how much is the total, class? It's 0.30.
3267.
0.3257. So what does it mean? That we expect that 32% of the population have a tax refund greater than $3,000. Yes?
Yes.
So that's a third of the population having that quantity of tax return. I want you to see, before I move to the other one, because it's similar to the one that we already solved, what happens if we use probability density for normal distribution.
¿Por qué restó 1 menos pues 3,000? Eso no me quedó claro.
Wait. I'll answer you in a second. Just wait. See how much is the probability with density for 3,000?
Very little.
0.0005. So it is not 0, but it's very close to 0. So tell me, for example, in this case, if we want to remove and make it 2,099, then the probability changing from 32.57% to 0.3252%. So in percentages, 0.02 percentage or 0.05 percentage is it's not that much. Okay.
Yes.
So
Okay.
that's why we work it that way. And that's the same answer that I was asking that we're not using subtracting the number. And why are we using 1 minus the 3,000? Because remember that this accumulation goes from 0 to 3,000.
El otro lado, ¿verdad?
Is the left side, exactly. And you want the right side. So when you want the right
La
side.
respuesta es 32.57.
Yes, here it is.
Okay.
Yes?
Arre.
Perfect. Questions?
3267, no?
67?
Yes.
3, 7, 4. Yes, true. 67. Oh. It's better if I erase it and then. Sorry. It's because look how super slow is my mouse. And I'm super. I can't believe. Oh, I'm making a 5 again. 67. I don't know. Let's leave it like that. So in this case, this one that is greater than 3,000, less than 350, how do we solve it?
Ahí se sacaría del 0 al 3,500 y después se le resta el 0 al 3,000, ¿no?
Perfect, yes. So let me erase all of this. And precisely the only thing that we need to do, My mouse is super slow. You have no idea how slow it is. So we will calculate from 3,000 and from 350. Sorry, 3,500. 3,500. With the same information. That information didn't change. So we make it 3,500. And we already have the one with 3,000, right?
Yes.
So we take the one with 3,500 and subtract it from the one that we got previously, which is this one. Because we always subtract the bigger from the smaller one. So we can keep with the part in between. It's not writing. Because we want only from 3,000 to 3,500. So we only want this part, okay? So the biggest one minus the smallest one. And how much is that probability?
0.2151.
0.2151. 0.2151. And that means that we have 21.51% probability, or percentage of the population in this case. Percentage of the population is expected to have tax refunds for or in between how much?
In between?
3,500 and 3,000.
From in between 3,000 to 3,500 or $3,500, right?
Mhm.
It was easier to type it than write it. Yes, class?
Yes.
Yes, teacher.
And those are the main differences in between the two of them. That's how you can solve the last part of your collaborative activity number 4. What I'm gonna be doing after we finish our class, so you can relax, is that I'm gonna be recording other set of exercises. But before we move, I want to check with you if we're able to identify which type of exercises we're working with, okay? Are you ready? Okay, so for example, let's see, this exercise that we have over here. In 2001, 50% of Americans believed that the country was going through a recession, although technically the economy had not shown 2 consecutive quarters of negative growth. For a sample of 20 Americans, perform the following calculations.
Binomial, ¿no?
Binomial, why?
Yes.
Pero hice una muestra de 20 personas.
We have a sample of 20 people
Y
and
We don't have a
50%.
standard deviation.
it's a 50%, so it can be 2 ways. One, because I identify the characteristics of the binomial, which is sample size and percentage of success. Or the other one is because we don't see the elements of the normal distribution, so we don't have information about the mean, we don't have information about the standard deviation, therefore it should be binomial. So,
yes.
Well done. Now you can move both sides. This one.
Binomial?
Binomial. Again, we have percentage, we have number of students, or the other way, we don't have mean and we don't have information about the standard deviation. Yes?
Yes.
Easy?
Easy
Yes.
peasy. Lemon squeezy.
The scores of an aptitude test are based on a normal distribution. It already says so. So
Normal distribution.
let's take it out. Phew. And it says that it has an average of 1,500 points and a standard deviation of 300 points. The school wishes to offer honorary scholarships to those students who obtain scores that place them in the highest 10%. What is the minimum score required to obtain the scholarship?
Distribution.
Is
That's
it normal?
normal.
It is normal. What elements do we have?
The
Standard
standard deviation and the average.
We have the average and the standard deviation, and we don't have percentage of success, and we don't have sample size.
Sample. Mhm.
Yes?
Yes.
Is it clear now?
Yes,
Very
teacher.
clear.
Why we don't subtract on normal distributions? I want to check that part. Why we don't subtract numbers or add numbers in normal distribution?
Because they are too small.
Because the probability is very small. And why do we have to be careful with subtracting one number before or after in binomial?
To
¿Puede repetirlo, teacher?
Why do we do subtract? In normal distributions, we don't subtract. In binomial, why we do subtract it in binomial? Why do we have to move from one element to another one?
Pues por la probabilidad de éxito y fracaso, ¿no? Bueno, algo así, no sé la verdad muy bien.
to get a specific range.
Because it is discrete. So a given number has a very big probability, so we have to be very careful with it and knowing which one we want to keep and which one we need to take out. Yes?
Okay.
Yes.
Yes.
Yes?
Yes.
Okay, so are you ready? Do you feel more comfortable now with those two concepts?
Yes, teacher.
Yes, teacher. Thank you.
Perfect. So I'll stop sharing so the video doesn't make super long.
Maestra,
Yes?
¿qué significa una pregunta